Larry is a star baseball pitcher. He enjoys pitching on his local team at school, as well as pitching in his free time. One day, Larry is alone in the park, on a day with no air resistance, and ponders over how long it would take for a ball to hit the ground if he tossed the ball X meters above the ground with a velocity of 14 meters per second, which velocity refers to the rate of change of the position of an object. Larry remembers learning of parabolic shapes, which is a two-dimensional symmetrical curve similar to the U shape. He learned of this in math class and how equations can be represented from such shapes. He then recalls the quadratic formula, which is a method that is used to find the roots of a quadratic equation, which has a squared term due to the root word of quadratus, which means squared. He plans to use the concept to figure out exactly how long it will take for the ball to return to ground level. Larry stands at a height of 3 meters. He learned at baseball practice that he throws right at around 14 meters per second, and he read from his science app that gravity, which is the force that attracts a body toward the center of Earth, mainly here in Larry's case, pulls down on the ball, changing the speed by about -5 meters per second. By adding these up, we are given the height, an equation which equates to h equals 3 plus 14t minus 5t squared. He then notes that he can find the time the ball hits the ground by setting the height equal to 0. Our new equation, 3 plus 14t minus 5t squared equals 0. At first, Larry tries to solve the problem through factoring, which is the act or process of separating an equation into its component parts, but realizes that the equation cannot be simply factored. So, he then applies the quadratic formula in order to find the two values for t, which equals to -0.2 and +3. Larry rules out the first, since time cannot be negative, which allows for him to conclude that the ball would reach the ground after 3 seconds.